Okay, so we are going to move on with the 11 o'clock material, explore a data frame of GISAID submission record. So if you click on the link, you actually see the file we are going to use, learning R through GISAID.rmd. This is actually in the unit 1. In the unit 1, there are two R Markdown files. One is the GISAID RMD file. The other one is Johns Hopkins COVID-19, which we'll use later on. So first we are going to use the GISAID submission file. So the GISAID submission file. So in your directory, in the unit 1 directory, you should see Excel file. GISAID monthly submission global something 2021 May 12. That's basically a global submission record I downloaded from GISAID on May 12 last week. And then we are going to analyze that Excel file using the learn R through GISAID.rmd, which is a markdown file. So on Mac, actually you can just open, directly say open that RMD file, and it's because I link it directly with RStudio, is actually going to open up in RStudio. On PC, I think you can right click and then say open with RStudio. Or you can, inside of RStudio, you can say open file, and then go to the folder. In this case, unit 1, start R with COVID-19. Then select learn R through GISAID.rmd file and then click open. So. Okay, so once you open that, and you will see a markdown file with a title. This is again is output in HTML with table of content in floating format. But you can also just use the R Markdown inside of RStudio. So that pound sign really means a title. I think that's header 1 something in Markdown format. So the first, maybe a little background on what GISAID is. In this case, Google probably is our best friend here. If I Google GISAID, well, on my search, the first one is the GISAID. GISAID initiative is global influenza surveillance and response something. But even though it's say I for influenza is actually now used a lot for SARS-CoV-2. So you actually need to register for this. Once you register, you will see it actually had EpiFlu and also now EpiCovid. So, but I guess the name for historical reasons still says influenza, but now it's actually a major source for SARS-CoV-2 monitoring. So, and I just download I think I forgot which file I download. Global submission statistics. That's probably the file I downloaded for this exercise. So, in fact, they updated almost weekly. So, okay, so that's the GISAID information. So this exercise basically for you to learn load Excel file into R, and then how to explore this Excel data file using R and RStudio. So that's we have a very this is just a very basic exercise. So okay, so in order to do that, we use a few libraries, tidyverse, and also a library to read Excel file. We also use a library called LubraDate. That's for handling date. So date is a very special data type in programming language or data science. So in normal data, if we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we know it's continuous, right? So after 7 is 8, but date is not the same, right? So you have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. After Sunday, it's Monday again. So you have a January 31st. After January 31st, it's not January 32nd. It's actually February 1st. So date is a very special data type for data analysis. And we use, so Luba date is a way for us to easily handle that. So, okay, so the next one, we're just going to load the data. In this case, I download that Excel file for you. Hopefully, if you click that green, what I forgot is I haven't run the first part. So we need to load the library first. There's, for many of you, if you run that, maybe your library has not been installed. In that case, you need to click the tools, install packages, and then put tidyverse, and Luber date, and read Excel there. So, and then you install all the 3 libraries all together. So you can also, and make sure also click install dependency, which every other library they call. So I'm going to give you a minute or two to make sure you can install all the tidyverse, Luber date, read Excel, and then you can run the code. So, and if people need help, and click and go to the reaction icon, click the raise your hand, and then in that case, you can also directly message the TAs, and then we can have a breakout room and try to troubleshoot that. Okay, I don't see anyone raise their hand. Do I see it? What's the name of the package again? Let me put it's, if you run the first section, it's going to remind you whether it's missing or not. So basically, it's tidyverse. Tidyverse, Luber date, read Excel. So if you just run the first part of the, if you do not have it, and then it's going to ask you to install it. And if you can successfully read the Excel file on your top right environment window, you should see now it has a new data variable called TB. I also use that for table. So it actually, if you click on that, you will see it says 174 observation of 19 variables. So variable actually is just the columns. 174 observation means 174 rows. If you actually open up the Excel file directly, so if I open that Excel file directly, you see it's basically it's a monthly submission of the sequence by each country. Oh, wow, even Afghanistan submitted 16 sequences recently, 2021 February. But Andorra submitted one, Australia seems to submit a lot. Austria also a lot. Yeah. So basically, those are the how many sequences those come by country has submitted to the GISAID database. So, each column is the month from January 2020 to May 2021, and then there's a total as the last column. Each row seems to be a country or a country-like area, I guess. 170. Oh, there's also a monthly total at the last row. So Zimbabwe, I guess alphabetically, that's the last country. Okay, but this is Excel. What we are trying to do is using R to analyze this data, to explore this spreadsheet. This is basically the very, probably the most important concept in R is something called data frame. I don't remember who came up with this term, but Python now also have the data frame. I think R probably come out first, then maybe there are other language come out first again. So data frame is basically can be considered as the object or the way how R handle a spreadsheet. So once we read into this TB is basically something called a data frame. In this case, if we look at the structure of the TB, we can actually, let's say, structure TB. Actually, this is something called this is also something called table, which is a specialized case of data frame. It is just tidyverse version of data frame. So, and we can also look just a few rows of the data frame TB, use a command called header. And for those who are familiar with the Linux, you remember on Linux system, we can use the header to look at the file. Right? So this is basically, since R is developed under Unix system, so it actually inherits a lot of Linux features. So header of TB is just look at the first few rows of the data of this data frame, basically a spreadsheet. So we have Afghanistan is the first country, followed by January 2020. That actually is not a date, that's a string. It's a word. Right now, that is treated as a word. It's actually not a date. We are going to convert that into a date later on. So and the way we can indexing. So one of the first things, once we have the data frame, how do we indexing a data frame? If we want to first, if we want to look at the first 5 rows and second and third column, we actually can do this. So, oops, finally, I still have some typos there. So if I say TB 1 to 5, 2 to 3, that would be there. They're all 0. That's not a good example, I guess. They're all 0. So, well, let's look at the few. Wait a minute. 2, 2, 3. That I should see a 3 there. Why I don't see a 3 there? Hold on, I'm going to separate that into different sections. That way I can see it more clearly. So, number 3, third row, third column, that should give me a 2, right? So 1, 2, 4. Do I see 2 there? No. would be really strange.
I think the first column is the country name.
Oh, yes, thank you. That's right. Okay, that's right. Yeah, so thank you. So the first one is the country name, second, third is actually fourth, right? Fourth column, sorry. My bad. Thank you. So now it's actually, now two is there, so, okay. Thank you. So, so, and we can also specify which row. So if I now says so which row is that? Third row, third column. So if I say I'm going to just look at the third row and third column, okay, I can just put that for that one. TV, third row, third column. That should be two. The fourth column. Sorry. Again, third row. Okay, now it's two. Okay, thank you. So that's and if I look at the third row and the fourth row and the seventh row with fourth column and fifth column, 2, 1. Yeah, 2, 1. Okay, that's correct. Okay, good. So now it makes sense. So we can actually also use a column name, which is probably more informative. So in this case, that would be March. So I'm going to change that to March. And so third row, fourth row, March 2020 and August 2020. So now it's also there. I can change that to April 2020. That should be one there. Yeah. So, I can actually update this on GitHub so you will know what I'm looking at. So I update on GitHub. And if you actually go back to the GitHub site, look at the code again, you actually will see the code I just updated. So if you have trouble to follow me, you can read that. Just download this file again, or it's then you'll have or you can just copy paste, I guess. So this is the code I just updated on GitHub. For convenience, I just use the GUI interface of the GitHub client. We kind of mentioned we can use the head to look at a few lines. We can actually use tail. Yeah. Instead of head, now we can actually look at the last few rows, and you can actually see the monthly total at the bottom of it. You can also specify the header information with a subsetting. So the square bracket, really means indexing. Maybe I should write specifically. Using square bracket. Okay, so if I knit this into HTML, and then we can also look at it using a table content feature to look at it. We loaded a library. And using the function read Excel, read that Excel file into R and save it in a variable called TB. That's the data frame. And this looks like a square. I have to put a space probably inside of that. Put a space there. So, and using a square bracket for indexing and using a comma to separate the rows. Before comma are rows, after comma are columns. Okay, so now I update. Before the comma are rows. Oh, I probably should have plural. After that are column. And so 3 means third row, 4 means fourth column. And with so many rows and columns, we can actually use the name directly. So in this case, March 2020, and this is April 2020. So. And we can actually use head or tail to look at a portion of the data frame. And one of the reasons to use a coding language instead of Excel is because coding language can do some analysis if we know how to do it, right? So basically, in this case, I want to find out how many columns in this spreadsheet. I can use length TB1, comma, space. This basically means how many elements in the first row, basically means how many columns. And so that means there are 19 columns. So we can also print on this. In R's print function, you can paste the string plus variables. So this is the output of the first row, how many columns there, and then I paste them with they are a column on the side. So the output will be they are 19 columns. This is actually very convenient when we use R Markdown to generate a report. And so for the student doing exercise, if you generate a report and submit the coursework, and this will be more readable, right? So. Let's say there is one thing very different in Excel and data frame is in data frame, everything usually are handled by columns. So, but in Excel, it seems like we, at least traditionally, many people want to handle things by rows. For example, Afghanistan is a country, every value there is a row. If we want to process all the data by country, we have to do it by rows. But in R, and actually in many other languages as well, the data are often handled by column. So if you look at the RStudio, you will see we have 19 variables. Now 19 variables basically means 19 columns. So in this case, if we want to take each column, we can say, let's see, If you want to see the second column, we actually have to list that. That's the second column. Or we can also say $sign there. I put a quote of the name because this is inside of those actually a string. So if you just type 01, that looks at the number there. So we can use $sign to access the columns in data frame. But this is not by country. This is just January, and that's not often not for data analysis. We may want to look at by country, and so in this case, what I'm going to do, I'm going to do a transpose, basically switch all the rows into columns, switch all the columns into rows, and well, but we're only going to do the values of this, not the country name. So, and this is actually something can be done by T transpose. So I'm going to take every row from second column to the last column. Length of that's the second one, 2 to the second, that's a value. And then I do a transpose. And then I put this into a new data frame. I call it a TB1. And then I'm going to name every column as using the first column. In the new data frame, I'm going to use basically those are country names. Use country names as column names in TB1. And then look at it. So this is how it look like after I finish these 3 steps. So now each row is a month, and each column is a country name. So now Afghanistan, February. Albania is 1, is that correct? We can double check, I guess, yeah. We can actually open up the Excel file. Let's double check that, whether that's correct or not. Albania generate, no, that shouldn't be 1. It looks like I made a mistake somewhere. Where did I make a mistake? This is, okay, apparently I didn't notice there's an error when I generate this. Well, I'm going to rerun everything to the top. See what, maybe not the TB. I need to do this step by step. Well, this is the good thing is yes, as a lesson, even though I have done this many times, I'm still making a mistake. I actually don't know where that mistake is right now. So I'm trying to find out where that mistake is. So we have to break it down. So first look at it. Okay, so I'm first look at a few rows. See, okay, this is correct. So it's not in this step. And then I do a transpose. That is also correct. Then, where did that mistake come from? This is really strange. This is also correct. Maybe the way I named the column are wrong. This is also correct.
I think you might just be looking at the wrong years actually, because you have tail instead of heads, 2021 instead of 2020.
Oh, thank you. I didn't realize that. Gee, that seems to be a pretty dumb mistake, isn't it? I just look at the wrong place. Okay, thank you. For a moment, I guess I didn't realize I was looking at the last part, but not the first part. So, thank you. Okay, I still have a typo somewhere. I guess I changed something there. Now I have a syntax error somewhere. Okay, now it's correct. That's really strange. Apparently, there's still a syntax error on type in that. Okay, let me just delete that. Okay. Oh, now it's correct. Okay, thank you. So, oh, I guess I didn't realize I'm looking at the tail instead of head. So, okay, now it's correct. My mistake. Apparently, when you do things on the fly, I didn't actually even read that line clearly. Even I thought it's head, but it's actually right tail. So, yeah, the human mind works in a very strange way. So. Okay, so those actually the role name are actually not a data type. I want to change that role name into a data type. Oh, actually, I use a zoo to do this, not a Luber data. So I'm going to just use this as is. Otherwise, the syntax will be different. So if you have not installed the zoo, you probably, I'm going to put this into separate lines. So if you have not installed the zoo, if you run this code, it's going to ask you to install the zoo as a library, so on your own computer. Once you install that, and we can do a plot of the submission of, in this case, we are using USA, and then plot it out by the date. Otherwise, if we have not converted the character into date, and then that basically will be just alphabetical order. It may or may not, even though in this case it happened to be correct, but it may not be the case if we use the January, February. Obviously, this monthly name are not alphabetic, so. Okay. And are people still following me? Apologize for the mistake. So. So in this case, we actually converting the row name into months and year, and then we plot it using something called ggplot. So the ggplot is one way. Is the entirely different new ways to do plotting. Is something called a tidyverse. So the tidyverse also use a different syntax than the basic R. There's actually a lot of material can go to how tidyverse do the plot and how ggplot work. The ggplot also use something called the additive plotting, so we can add the feature up. So ggplot, that's the table 1. and that's something called aesthetics. And then we specify X is the date, and then Y is the USA columns. And if we do that, there's nothing there. And then it's actually just a blank plate with the USA, the y-axis, and data, the x-axis. But then we can add more features. And in this case, we're going to add geo point, and they basically do a scatter plot. So there. So apparently the United States didn't submit very much in the whole 2020. So only recently started submitting sequence to GISAID. January, February, March, April. It looked like April US submit a lot, and in May dropped again. So. And we can look at the table ones. And those are just country names. So the USA will be, where's the USA? There, that's USA. So 163rd column is USA. And we can also just look at the USA using this $sign symbol. So we can use $sign to take a specified column. So in this case, sorry, my mistake. USA does submit several thousand in 2020, but because in April it submitted so much, 139, it just makes those several hundred become very small. So those are all basic R usage. In tidyverse, there's also another syntax, something called pipeline. So this is tidyverse. In tidyverse, we can use select and then use the pipeline to chain those commands. The table one, and then this is pipeline. And if you have used Linux, you know Linux can also chain a command using the pipeline version. So this is going to select USA, basically select column, basically variable. That's the same result. So so that at the top we use the $sign to index that column. At the bottom, the next chunk, we are using tidyverse to select USA, and it's basically the same operation but different syntax. And apparently, so someone in breakout room number 2 is asking for help. Can a TA join there? So. Okay, yeah, I see a TA there. So. And in tidyverse, future is by rows, future by rows. So tidyverse is a very recent development in R, and it is almost like the, well, if some of you are old enough to remember when the computer first started, it has a Windows PC computer use DOS and then come up with Windows. So the tidyverse in R is almost like a new version, almost like that. We have the basic R, you have the $sign, square bracket, but then tidyverse come out with a new syntax with this pipeline. It actually makes some things more convenient. So I'm not saying this is the new, it's almost like a different syntax. So you would really need to learn that, spend more time on the tidyverse to be more comfortable with it. So, and the basic R still works. So philosophically speaking, maybe strictly using tidyverse or strictly using basic R are recommended. That way you don't have a switch between two different flavor or language. But that said, R is still used mostly for statistical analysis, and most of the statistical packages are still in basic R. But many of the data visualization packages are now moved to tidyverse, especially a lot of publication quality figures. They are mostly generated using ggplot or more fancy way like Plotly. So from the practical perspective, it's still good for people to learn how to do things in basic R, and then for visualization or data manipulation, you need to learn how to do that in tidyverse. Basically, that's how I have been practicing. So there are some things using a basic R is very cumbersome, but in tidyverse, you can do it very easily. But then there are statistical package and many sophisticated analysis are only available in basic R or much easier, at least when I do it, I found it more comfortable using basic R. Also because tidyverse really trying to hidden a lot of a black box, hidden a lot of operation as a black box, and I don't feel comfortable with that when I'm doing a statistical analysis. I want to see what I'm doing. I don't want to see a black box. So so I'm actually more comfortable with using basic R to do a statistical analysis. But for visualization, ggplot or tidyverse is very helpful. So I see Kathleen Jarvis also need help. Can you join the breakout? Can you join the breakout room number 2? Can you join the breakout room number 2? See whether yeah, breakout number 2. The TA is still there. So yeah, thank you. Okay. Anyone else having trouble with this? So we can also combine filter and select, and just like any command or function, you can combine them. So it's flexible. So tidyverse is also programming language, programming practice, I guess. So if we now filter USA greater than 1, basically remove the 0. Are they 0? No, they are. Nothing is 0. So I'm going to filter greater than 100. How about that? And then we select USA and China as 2 columns. Now look at this. There. So now we have what? Yeah. USA. Apparently, China seems to protect its own sequences. So China has its own data submission, almost like NCBI. So most of the Chinese side sequencing are submitted to the something called Chinese side GenBank. But GISAID, the US seem to be submitting to GISAID. My understanding, many of the China's sequencing the GISAID are collected by GISAID themselves. Not many of them are not directly submitted from China. But even though the origin, the sequence may be done in China, so that's why I'm just guessing. So. If we want to double check TB1, the USA. If we want to double check, see whether that is the same. Okay, yes. So there, I filtered out 5 and 13 because my criteria is I only pick rows with greater than 100. So maybe I should put this in different windows. Oh, Mira, oh, I see you are directly, Mira, you need to directly message Kathleen, then she will see it. So, or you can join room 3 and then ask her to move to room 2.
Yeah, apparently it's not there. I can't directly send a message for some reason.
Oh, cannot. I can put both of you in room 2 directly.
Yeah,
Let me see. I can move her to room 2. Room 2? Are you saying room 3? Room 3?
Room 3, yeah, room 2 is busy. Yeah, room 3.
Room 3. Okay, I move both of you to room 3. So if I generate HTML output, see, maybe we'll then we will see the result next to each other. Okay, so now let's see. Apologize for my typos. Yeah. Rows. Yes. So now I have the USA MM3, and then at the bottom you see the USA 5. So that row is not in the data, but it has been filtered out by this command, filter USA greater than 100. So we can also combine the logic of this. So I can say filter USA greater than that, and less than 1,000. About that. There. So no, that is not there. Less than. Oh, I see. Yes. Oh, that's just one value left. 5,000. Okay. Yeah. Okay. So now, if I regenerate the okay. So now, okay. So now we are picking the rows greater than 100, less than 5,000. So let's see. That means, well, the April will be gone, 8,000 will be gone. 13. Oh, there's actually a whole lot gone. So, so now we only have the rows. Yeah, it does 4,700 is still less than 5,000. So this we can combine the logical operation as well. So after combining, we select a column USA and China. So we can actually this actually monthly total. You can also operate and see what percentage of USA are contributing. So in this case, let's see. That's the monthly total. Yeah, so right now, it's actually the GISAID has 3 million sequence now. Wow, that's really a lot. If you want to do a sequence alignment, you have to deal with 3 million sequences. So that's quite a bit. You need a very decent memory to do that, a computer with a RAM to do that. So we can convert the USA TB, USA percentage. Basically, see how much percentage have the USA contributed. Well, that's not TB. TB1. Did I call it TB1? Right? TB1 USA divided by TB1 monthly. I'm going to separate it into different chunks. That way we can see it separately. Oh, I need to print them out. Wow. Apparently, in recent months, USA is contributing more 29, 27%, or even 35% monthly. Wow, that's quite a lot. So, but initially, it only contribute less than 10%. Oh, but even there is quite a lot, 25%. So even though initially it's very small, but that's still 25%. I guess the overall submission is low. Yeah, that's this is what apparently using R and RStudio you can more easily manipulating the data as you deem appropriate for your purpose of data analysis. I guess. Yeah, so the last part is just want to show, since that's the monthly total, I sum up everything that should be the total sequence submitted. But that's a very large number. I don't know what it is. So I divided it by 1 million to see how much it is, how big it is. So it is 3 million. So bigger than, I divided by 3 million is 3.02. So it's a 3,020,000 something. Yeah. So. And okay. So this is it looks like we are again right on the schedule. So this is the exercise to explore data from GISAID. In fact, many of you want to analyze GISAID, you may actually want to download more from the GISAID website. There are a lot of information there. You can try to play with it. It's good motivation for us to actually to see this can be put into good use, I guess. Yeah. So we are going to have a lunch break, and then when we come back, we are going to use R to analyze COVID-19 data cases. That's a data set from the Johns Hopkins data set. In fact, if you Google, you will see that JHU COVID-19 CSSE. You will see that. GitHub. This is it. Actually, no, that's not. I should add it. Yes, this is it. Yeah. So this is basically the data set we are going to analyze using R and RStudio. So, okay, let's have a lunch break. Yeah. Any questions? Okay, yeah. Let's have a lunch. We come back at 1 o'clock. Yes, let's come back at 1 o'clock. Bye, everyone.